Hello everyone, my name is Raid. First I'm going to introduce my group members Apala and Bisrat. Now our topic is performance of automata minimization algorithms. There are several algorithms to minimize DFA. Apart from theoretical worst case running, practical performance is more important. On this paper, we compare three minimization algorithms. The comparison of algorithms performance is always a difficult issue because of little is known about the practical running time. The choice of algorithms was based on the worst case scenarios of performance.
A deterministic finite automata M is a phi tuple consists of a finite set of states Q and finite set of input symbols called the alphabet sigma, a transition function, a initial state, and the set of acceptance states. Coming to the non-deterministic finite automata, the NFA is represented formally as a phi tuple consists of a finite set of states, a finite set of input symbols, transition function, an initial state, and a set of states distinguished and accepting or final states. This minimization algorithm consists of three: the Hopcroft's algorithm, Brzozowski algorithm, and the Watson incremental algorithm using random automata generation. Coming to Hopcroft algorithm, this Hopcroft algorithm computes the minimal automation by refining a partition of a state set. The initial partition P consists of a transition and the final states, and each step of the algorithm block B, P, and a symbol which A belongs to sigma are selected to refine the partition. Formally, we call this procedure split and define it by split B, B, A, and the algorithm terminates when there are no more blocks to refine. Brzozowski algorithm. This algorithm is the only one able to process both DFAs and NFAs. Brzozowski algorithm can be stated as a simple function because the algorithm is defined in a set of two statements where the composition of the previous procedures, which consists of determinant, reverse of an algorithm, and determinant and reverse of an algorithm. Brzozowski algorithm is simple and elegant. Despite its exponential worst case complexity, it is supposed to frequently outperform other algorithms.
The incremental algorithm used an auxiliary function equi that tests if two states are equivalent. The third argument, an integer k, is used to control the recursion depth and is used only for matter of efficiency. For matter of efficiency, a variable S that contains a set of equivalent pair of state is made global. Minimal P that calls equi for every pair of state and return false if some pair is found to be equivalent. Experimental result. To compare algorithm is always a difficult problem. On his thesis, Watson used a fairly bad sample. It consists of 4,833 DFAs, of which only 7 had 23 states. The following graph shows the running time for the third algorithm while minimizing. Conclusion: we compared three automation minimization algorithms based on the experimental result. It is important to note that the random generation they used was not uniform one, and so it is possible that the random sample are not a good representative state. Brzozowski algorithm was definitely the fastest algorithm for NFAs. Hopcroft's and Watson algorithm was slower than Brzozowski algorithm, always slower, similar result.